Yes. Good morning all, and welcome to the another lecture of electronics, semester one. And on behalf of Department of Electronics, Sri Mathura Das Mohta College of Science, I welcome you all for the first lecture of your syllabus of your academics. So, as we started in the last class, we have studied about some of the basic introduction of electronics. So we will just brush it up and then we will go to the next topic. So let me share my screen. Okay. So yeah, here it is. Right. So I hope my screen is visible to you all. If it is not visible, kindly let me know so that I can do something for that. Yeah. Is my screen visible to you? Am I visible? My screen is visible.
Yes, sir.
Yes, sir.
Thank you. Thank you. Thank you. So yeah. So what I was telling you that I welcome you all for the first lecture of electronics, and I wish you all the best for your academics as such. So we have started with some of the introduction of a basic introduction of electronics in the last class, and today we'll continue with that only. So the first that we have studied was uh, yeah, introduction of electricity that we have studied in the last class. So just give me a moment. And we have studied about the charge. Yeah. So what was the charge? So a charge is, let me admit here. So symbol is Q, unit is coulomb, and the fundamental electric quantity is called as a charge. So that is what we have studied earlier: negative charge and positive charge. Then what is current? The symbol is I, unit is amperes, and the rate of flow of charges in a conductor is called as a current, right? So, and the electrons flows in the opposite direction of the current. So this is a wire that I've shown you, and this is the equation for that. dq by dt. I is the current, and q is the relative charge, that is electrons in coulomb, and ampere is coulomb per second. So this is always measured in milliamperes. So uh, that is for current. Then we have studied about the current volter analogy. So this is the current that we are having. So it's similar to a tap that through which we receive the water, and we can control that accordingly. We can move the tap. So as the electrons are dense over here, there will be more current. When there is less electrons are present in a conductor, the less current will flow through that. So this is the current water analogy of current water analogy. Then we have started with the voltage. The voltage is, the symbol is V and unit is volt. That is the potential difference between two terminals in a circuit. That is called as the voltage. The difference between the potential energy difference, right? That is called as a voltage. So we have studied this also, and I have just brushed through. And this is what I have already uploaded on my YouTube. So go through that. So this is A and this is B point, and the potential energy difference between these 2 points is called as voltage, right? Then we have studied this voltage and water analogy circuit. So we are having a tank full of water over here. So we are having a bigger tank at a very high height. So there is the amount of water which is flowing is high. Then if the tank is near to that tap, then the speed of the water is low, right? So that is the voltage water analogy circuit. Then voltage current water analogy circuit. So both are here over there. So as you can see here, we are having four batteries: 1.5, 1.5, 1.5, and 1.5, and we have connected it in series. So as we connect it in as we connect the batteries in our remote controls that we use of TV and all, so those are being connected over here. And if you are able to see that the current which is there, if we have a full connection, then the lamp, that is the LED or light, it will grow brighter because it is having 6 volts, right? And the current flowing through that is maximum. When it connects to the 3 supply, then it is slightly dimmer, and this is slightly dimmer again, and the last one, that which is connected to only single battery, will be very dim. So this is, and accordingly we can have this type of arrangement. I hope it is visible to you all. This is a jar which is filled with water, and it is having 4 openings. And if you are able to see that at the top of the in the top of the from the top of the opening, there the water which is coming is having a less speed, whereas as compared to the last, the lowest opening over there is having a speed. So the pressure that is generated over here can be depicted by using as a current. Right? So that is the current over there. Series connection of the cells, I have already told you, if we connect these cells, batteries in series, then the voltage is being added, right? So this is series connection. Then we have the parallel connection of cells. Now, if you add 2 cells in parallel, then the voltage remains same, but the current might increase. So it will give more current. So this is the parallel connection of cell. Then wire water analogy circuit, it's similar to a pipe. The pipe the water flows, and in wire the current flows. So it is wire water analogy circuit, and this is what we have already studied. Resistor concept. Yeah. So resistance. What do you understand by a resistance? Today we are going to explore this. Resistance means, the simplest meaning of a resistance is the which resists something is called as a resistance. The material which resists current is called as a resistor. And as much it is resisted, the current, the resistance is more, right? So by that view, we can say that in a conductor, the resistance is very low, very, very low. That is why maximum current flows through a conductor. Whereas when we talk about a insulator, from where the current does not flow at all, then the resistance of that insulator is infinite. Insulator means which is a bad conductor of heat and electricity, is called as an insulator, right? Or a non-conducting medium. So the resistance of a non-conducting medium is maximum. That we can say it as infinity. That is why the no current flows through that. The simplest example is, if I have a wire and if I break it from a center, and if I want to pass a current through it, there will be no current flowing through it because it is break. So in that case, what we say, that it has got the maximum resistance, that is infinite resistance. So as good as an open switch, right? Whenever a switch is open, it has got infinite resistance and no current flows through that, right? So resistance is expressed in ohms, that is the unit, and this is the symbol of that. And this is named after George Ohm, who discovered it. And it is always mentioned in terms of kilo ohms, mega ohms. We will be seeing this units also, right? So this is there, and yeah, this is the this is not actual diagram of resistance. I will show you this. So it has got the insulating coating. It is just a functional, or let's say understanding diagram of resistance. Then this is a symbol, and this is a symbol for Europe, and this is a symbol for USA, Japan, right, of a resistance. And we are going to use this symbol, the curved one, right? So this symbol is generally used while we are showing it in a circuit. So this is the resistance. Second concept of resistance is it dissipates heat, right? So it dissipates heat. As much of heat it generates, then the resistance is higher. So that is there. Then this is the resistor water analogy circuit. When we pass water through a pipe having some obstacles or some stones over there, then minimum water is going to flow through that, right? So that is how the resistance works. So every load or every device which we want to say work on through by using the voltage and the current, then that particular is having a resistance, this resistance. Say for example, if you want to switch on the light bulb, then it will have its own resistance, and accordingly it will suppress the current. It won't pass the current, right? So this is the simplest circuit that we are having, and this is called as a load. Load, the device or the component which we need to drive by using this voltage and the current, right? So that particular is called as a load or a resistance, right? So this is there, and this is some of the examples that is given over there. Then this is the resistance that I have shown you, and yeah, resistance VI characteristics. Now, in every of the practicals that we are going to study in this session will have a VI characteristics, which means that voltage and current characteristics. So voltage are to be taken on the x-axis, and the current is to be taken on the y-axis, and accordingly we draw the graph, right? So we call it as a VI characteristic. VI characteristics means voltage and current characteristics. So as we go on increasing the voltage, what are the parameters of current that are going to change, and accordingly we'll have a graph. So we call it as a VI characteristic, right? Now in this case, we say that I is directly proportional to voltage. That is, the current is directly proportional to the voltage. And if we are using a proportionality constant, then we put G as a proportionality constant. In some cases, we put it like R, right? And this G is called as, equivalently, this is called as V equal to R into I, right? So this R is called as the resistance. And we say that V equal to IR. Now this is the called as Ohm's law, right? So Ohm's law is voltage is directly proportional to current, and the constant in proportionality, that is R, we are going to take is the resistance. So V equal to I into R, right? So R equal to 1 by G. This is the conductivity that we are calling. So conductance is G, and R is termed as the resistance of a conductor, which is given by ohms, and this is the symbol. Whereas G, that is called as the conductance, is the reciprocal of ohm, that is mho MHO. So this is OHM and this is MHO. So conductance, the unit of conductance is mho, and it is reciprocal, right? So topsy turvy, ulta hai ye, right? So this is the proportionality of resistance, and this is how we derive the resistance. Then resistor applications, we all know that resistance are used for limiting current, right? So whenever we connect a LED in a power supply, we require a resistance over there to limit the current, and that is called as the limiting resistance, right? Second applications is for lowering the voltage level. So we can use it as a voltage divider circuit that we have to study in this session. Then we can use it as a current provider, that as you go on increasing the resistance or decreasing the resistance, accordingly the current is being increased or decreased. As a sensor, we are having different types of resistive sensors, like photoresistor, which detects the light condition, then thermistor, which detects thermal resistance actually, so that detects the changes in the temperature, and yeah, and the electronic circuits, where we are having some pull up and pull down elements to avoid floating signal levels. So we need to restrict those signals, and accordingly we require some of the resistance over there, and these are some of the applications of resistance. Now let us go through the power ratings of resistance. Now, what is a power? So power is actually termed as the product of voltage and current, right? So voltage and current gives us a power. So you might have seen in bulbs that it is written as 100 watt, 60 watt, right? So this watt is actually the power, the consumption that a particular component or a device is going to have, and that is termed in terms of power. So we write it in watts, right? So it is a very important to be aware of power rating of a resistor, because we are having different types of resistance: quarter watt, half watt, 1 watt resistance, accordingly, according to our requirement of the circuit that we can have. So that is called as the power rating. So we should understand that where we are going to put that resistance over there, and accordingly we need to know what is the power rating of that. Uh, what is the power rating of that particular resistance, and what type of resistance is being required over there. There are different types of resistances: carbon film resistances, carbon composition, metal oxide, precision metal film, high power wire wound. These are all types of resistances that we use generally. High power wire wound resistance are being used in the regulators, the fan regulators that we were using earlier. The click 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 वाला जो पहले आता था, उसमें हम लोग इसको यूज करते थे. So this was the power ratings. Yeah, these are some of the examples. So let us go through these examples. So this is the symbol of resistance, USA and Japan, and we are also going to use this. And these are some of the contact leads. These are the color coding of resistance, and this is what I was telling you. So according to the power rating of resistance, the size of that resistance goes on increasing. So this is a quarter watt resistance, so the size is very smaller. Half watt resistance, the size is still bigger than that. Then we have a 1 watt, 2 watt, 25 watt resistances. So we are having all various sorts of resistances, and as per our requirements. Actually. So these are some of the examples, and these are the symbols. So these are some resistances that are being shown over here. So this is the quarter watt, this is a half watt, 1 watt, 2 watt resistances, and accordingly, these are some of the higher wattages resistances which are shown over there. So all sorts of resistances are there, and this is what we are expecting to study. These are called as resistor labels. Accordingly, we can calculate what resistance the what type of resistance is having by that component, right? So we can calculate that. How we are going to calculate this? So we are having some bands on this resistance. So actually, we are having generally 4 bands on those resistances, like it is written over here: A, B, C, and the last one is the fourth band that we call it as the. I guess it is written as COL. So that is called as the tolerance band. So the main band is these 3 bands are there. So we call it as A, B, and C. So if you need to calculate the value of that resistance, then what we need to do is we have to add this. We have to just write this AB. So we are written over here AB, and multiplied by 10 raised to the power the third band, that is C. Now, what are the values of these bands? So that is what we need to know. So for that, we have this say symbol of the color coding of the resistances. So this is the color codes of resistances. In say uh, in our normal day, what we need to say is what we used to do is let me, yes, I can escape this itself. So yeah, what we used to say is we have. I hope I don't have hope that we are having that. So what we used to say is we'll just write over here so that you should be able to understand. Where is it? Yeah, this is text. So what we usually need write accordingly. So I just basic. So we used to write B Roy of Great Britain got a very good wife. So this was actually a formula where we actually want that you should be able to understand what I mean to say by that. So this is there. Yeah. So it will make it a little bit darker. So this is the where we need to study what I have written over there. Uh, just remember this sentence: B.B. Roy of Great Britain got a very good vibe. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So yes, some more people are still joining. So got a very good wife. So this must be G. So whatever capital letters we are having over there are being used. Yeah. So this is what we say. B.B. Roy of Great Britain got a very good wife, right? So B, whatever there are, the capital letters are there, we use those. So this B stands for this black, this B stands for brown, this R stands for red, O stands for orange, Y stands for yellow, then G stands for green, B stands for blue. Uh, we don't have purple as such. Then we have gray, then violet. Yes, violet is there. Okay, so I guess this G is not capital. This G is capital. Yes, so it's there. Yeah. So I guess you have understood. B.B. Roy of Great Britain got a very good wife. Yeah. So we are having this as violet. Then we are having gray and white, right? So these are 10 colors, and accordingly, these are some of the digits which are allotted to them. So zero, it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So according to that, if we have a multiplier, then it is multiplied by 1. If it is, say, just first or second band. So accordingly, we'll have that. And then we have the tolerance as three bands are there. Brown, sorry, five bands: brown, red, gold, silver, and none. So if there is a brown band at the tolerance at the four band, then it is having plus minus 1%. The other one is plus minus 2%. Gold is having plus minus 5%. Silver is having plus minus 10%, and plus minus 20%. I will let you know what it is. So just remember this. The sentence for the color coding is B.P. Roy of Great Britain got a very good wife. This statement you are able to say remember, and accordingly you can make a chart of this. So accordingly we will have black, brown, red, orange, yellow, green, blue, violet, gray, white, silver, and gold. Right. So this is there. Then now how we are going to use it. So the first digit is yellow. The first band is yellow, so the first digit is 4. Then the second band is violet, right? So violet is there, so the second digit is 7. The third band is red, which shows that it is second band 2, third band that is 2. So the multiplier is 2. So we can write here 4, 7, that is 47, multiplied by 10 raised to power. The red one is having 2, so 10 raised to power 2. And since we are having gold as a tolerance, so it is having plus minus 5%. What it implies? The tolerance is plus minus 5% means if we are having the resistance as 100, then it might have 95 or it may raise to 105 plus minus 10% of the exact value which is expected to come, right? So accordingly, we can have the value of the resistance by using these color codes, right? So this is the first practical that I was expecting that you should perform. So that is that of the color band, right? So I might have given when the offline classes will start. I'm expecting you to give this resistance to you, and I need to I want you to calculate the value of those resistances by using this color code, right? So you should know what type of color codes we are using. Now, let us go to this. So metric units and conversion. I hope this is the most important part of any of the unit system. And this is what we need to connect this. And some of them are, you might be using that, right? So that you are using is this milli, that is M. So this milli means 10 raised to power minus 3, right? You use it like millimeter, milliliter, and say milli-degrees, right? So you use those words. In our case, we can use it as millihenry, milliamperes current, right? So milli we use. So that means it is having a value of 10 raised to power minus 3. And when we say micro, that is 10 raised to power minus 6, nano 10 raised to power minus 9, pico 10 raised to power minus 12. Uh, in the upward direction, we are having kilo. So 1 kg, we call it kilogram. So that is a kilo only. Kilometer, kilogram, kiloliter, or say kilo ohms, kilowatts, like according. So kilo means 10 raised to power 3, that is 1000. Mega means 1 lakh, that is 10 raised to power 6. Giga is 10 raised to power 9. And there is one more, that is tera, that is 10 raised to power 12. So accordingly, we are having this abbreviation and units. Then we have to start with, say, multimeters, but we expect that today we are not going to do that. I guess today is enough for this, and I expect that you have understood this class. If you have any queries, you can ask this. So I guess we have started with yes, resistances only. So we will continue with here. I'll just repeat it for you. Resistor concept. So the flow of electric current through a conductor experiences a certain amount of resistance. Resistance means which resists something, and in our case, which resists current is called as a resistance as far as electronics is concerned or electric components are concerned. So the component which resists current is called as a resistance, right? And it is the unit of which is called as ohms, in the name of George Ohm, which invented this resistance, right? And uh, this is detected on the properties of the material that we are going to use, and that limits the current also. This is what we have studied. This is the basic structure of a resistance that we are using, and these are the symbols. Resistance. Then we are the second concept of resistance is the heat that is being generated and dissipated. Then this is the water and resistor analogy circuit. Accordingly, if there is more resistance, then there is less amount of less amount of water flowing through this pipe, and that can be shown. And similarly, if the load is maximum, then there is no current flowing through that. So these are the structures that we have studied. Then VI characteristics we have started. So we know that the current is directly proportional to voltage, and if we put a proportionality constant, we will have I equal to G into V. On the converse side, we can have V equal to I into R, that is the Ohm's law. And accordingly, the resistance is being derived. So resistance is nothing but the say ratio of voltage by current, right? So that is written over there. The units are conductor ohm, and for conductance we are having mho, right? So resistance application we have studied, and these are some of the power ratings which are very necessary. Then these are some of the examples of resistances, and these are the color codes that we need to understand how we are going to calculate the value of that particular resistor. So of course we are having 4 or 6 bands of colors. Generally we have 4 color bands. So the first A, B, and C, and the fourth one a little bit different from the three from these 3 bands. So the fourth band is for the tolerance, right? And these are according to this color coding. So we have a formula like BB Roy of Great Britain got a very good vibe, and accordingly we derive these colors, right? And the digits or the numbers of those colors. So black is having 0, brown is having 1, red is 2, orange 3, yellow 4, green 5, blue 6. This is not purple, this is violet, that is 7, gray 8, white 9, silver, this is for tolerance. So this is plus minus, say, plus minus 10%, and this is gold is plus minus 5%. So these are the tolerance, and the fourth band is having these 5 colors: brown, red, gold, silver, and there is no color, right? So none means there will be no band in the fourth place. So if there is no band, which implies that it will have a tolerance of 20%. Means if the value of the resistance comes out to be 100, then it might be say 80 or it might be 120. So it might fluctuate between 80 to 120, anything between that, right? When it comes to brown, then it means that it will be a very error-free type of a resistance, and it is very accurate resistance, right? It has a very minimum fluctuation. So this is the color codes. Then this is how we can calculate. So the first band and second band are written. The numbers of first and second band are written directly, 4 and 7, so that is 47, and multiplied by the 10th power of the third band, that is 10 to the power 2. And the fourth band gives you, that is the gold. So it gives you plus minus 5% tolerance. So that is the resistance. And these are some of the units which you might be able to remember. I expect from your side that you should just take a snapshot of these things. And also, I will be uploading this video on my YouTube channel. So go through that channel and view these videos. You can view these videos many times as much as you can like, right? So just hold it for a second. Yeah. So if else you have any, so thank you very much for patience listening and visiting my YouTube channel, and go through that and keep watching and send me comments so that I should say I should update myself accordingly as per your requirements and your feedback. Thank you very much. See you soon. I guess we will be having the next class tomorrow at the same time at 1:55 or 2 o'clock. So by that time, take care.
Thank you, sir.
Stay home, stay safe, take care. Good day. See you soon. Bye.
Thank you, sir.